One day when you were a kid, you probably sat down to watch your favorite movie, only to see this message. For some of us, this was probably the first time we heard of epilepsy. But what is epilepsy? What does it do? Why couldn't they watch this movie? Well, let's find out. Epilepsy is a range of neurological disorders in which the brain's electrical activity is altered, triggering recurrent seizures. In some cases, epilepsy arises from brain trauma such as injury, stroke, tumor, or infection, as well as birth defects, and a few cases have been linked to specific gene mutations. Unfortunately, however, in most cases, the root cause of epilepsy remains unknown. What we do know is that there are currently around 50 million people worldwide living with the condition, which can claim upwards of 100,000 lives per year. There are 250,000 people in Australia with epilepsy, and due to the limited healthcare access, Indigenous communities are overrepresented within this group, with more frequent and longer hospitalizations. In developed countries like Australia, the most frequent age of onset is in babies and the elderly. Neurons in the brain transmit electrochemical impulses to produce thoughts, feelings, and movement. In a healthy brain, neuronal signaling is non-synchronous. In other words, neurons should fire alternately rather than simultaneously. On a closer level, these electrical signals are the result of ion movement through channels, which triggers the release of neurotransmitters. These chemicals then bind to their respective receptors to cause subsequent ion channel changes. To balance this signaling, neurons can either have an excitatory or inhibitory action. Excitatory neurons release neurotransmitters such as glutamate, which binds to NMDA receptors to cause channel openings and propagation of the signal. Inhibitory neurons release neurotransmitters like GABA, which bind to GABA receptors to cause channels to close, preventing signal transmission. These neurons are responsible for preventing continuous electrical activity. However, continuous electrical activity is exactly what is seen in seizures. The alternating communication is gone, and neurons begin synchronously firing. There is no singular clear mechanism which drives this transition into abnormal activity. Research has suggested several genetic mutations leading to the development of epilepsy, such as those impairing sodium channels, potassium channels, and sodium-potassium ATPase pumps. Mutations which affect GABA receptors and interneurons can cause inhibitory circuits to become dysfunctional, leading to neuron hyperexcitability. Similarly, extended activation of NMDA receptors causes overstimulation of excitatory circuits, resulting in hyperexcitability. Additionally, astrocytes have been shown to be key regulators in extracellular ion and neurotransmitter concentrations. If damaged, for example, glutamate can accumulate within synapses and cause abnormal excitation as a result. Unfortunately, the result of all this neuron hyperexcitability is seizures. Seizures are classified according to where they originate in the brain, either from a localized group of neurons, known as a focal, or throughout, known as generalized. Each type has many subclassifications according to the symptoms displayed. Focal seizures arise when a region of neurons begin misfiring synchronously, as shown earlier, and will elicit specific signs according to the location affected. For example, an individual may experience full or impaired consciousness, and they may seem intoxicated or confused. They may exhibit some jerking movements, experience tingling sensations, sweating, impaired speech, or sudden emotion according to the brain region afflicted. Generalized seizures tend to be associated with more severe symptoms, usually involving an instant loss of consciousness, and the person may well fall to the ground. There are several subtypes of generalized seizures, including the most notable tonic-clonic, with rapid whole-body convulsions. Myoclonic seizures cause single muscle group jerks, whilst tonics cause sudden stiffening. Atonic seizures are the opposite, causing sudden loss of muscle tone, whilst absent seizures indicate a momentary lapse in consciousness with a blank stare. Seizures can be even further classified according to their triggers, if known. For example, flashing lights causing seizures in those with what is known as photosensitive epilepsy. So there you have it, everything you might have wondered about epilepsy in hopefully less than 5 minutes.